Okay, so we're going to take a look at the ambiguous case. And the ambiguous case means that we may not have a unique triangle. So when solving a triangle, you must analyze the given information to determine if a solution exists. If you are given the measures of two angles and one side, so angle, side, angle, then the triangle is uniquely defined. Now remember, angle, side, angle is the same thing as angle, angle, side. Both of these will give you a unique triangle. However, if you are given two sides and an angle opposite one of those sides, so you have side, side, angle, the ambiguous case may occur. And in the ambiguous case, there are three possible outcomes. You can have a situation where no triangle exists that has the given measures, therefore there is no solution. You can have a situation where there is one triangle that exists that has the given measures, so you have one solution. Or a situation where you have two distinct triangles that exist with the given measures, and therefore you have two distinct solutions. These possibilities are summarized in the diagrams below. Suppose that you are given the measures of side B and angle A of triangle ABC. You can then find the height of the triangle by using h equals b sine A. So let's see where they get that from. So let's draw a triangle, A, B, and C. And we know angle A, so I'm going to put a dot in that vertice there to show you we know that angle. And we are given side B, so I'll label side B. So let's draw an altitude in then for our triangle. So let's drop a perpendicular line from C to the base. And as you can, and let's call this point right here D. Okay. So you can see that we have a right triangle here, okay, which is called ACD. And let's label our height H. So if I'm given angle A, then the side opposite to angle A is side H. And for triangle ACD, the hypotenuse is B. So if I want to find or come up with an expression that uses angle A, H, and B, I'm looking at sine, right? Because H is opposite A and I have the hypotenuse. So the sine of A is equal to H over B. Now if you take a look over here, they're telling us that H equals B sine A. Well, I can get that by multiplying both sides of this equation by B, and so I get that H is equal to B sine of H, or A. So this expression will give me the height of my triangle. So in triangle ABC, angle A and side B are constant because they are given. Consider different possible lengths of side A. For an acute angle A, the four possible lengths of side A result in four different cases. Now, just a reminder that acute means between 0 degrees and 90 degrees. So your angle A will be between 0 and 90 degrees. Okay, so let's take a look at our four different cases. In our first situation, all right, so remember we are given angle A and side B. Those are constants, okay? So this is a given and side B is our given. What we want to know is what happens to our triangle when we're given certain lengths of A, okay, different possible A lengths. All right, well, let's take a look at the situation where A is less than H, meaning that A is shorter than the height of our triangle. In other words, A is less than the height of our triangle. All right, I just said that. Okay, so if I swing arm A, so let's say there's a hinge here, okay, and I swing arm A to the left. You can see that it's never ever going to touch the base of this triangle, okay? And because it's never going to connect with the base of my triangle, there is no solution, okay? So when A is shorter than the height, there is no solution. And remember, A has to be an acute angle. Okay, in our next situation, the side A has exactly the same length as our height, okay? So A is equal to H. Remember, B sine A is just another expression for the height, so A is equal to the height. And there's only one possible answer here, because even if I swung A out to here and it has the same height as H, it won't touch the base of the triangle on this side of the altitude of my triangle, the height of my triangle. And if I swing it to the left, it won't touch the base on the left either. Okay, so there's only one possible answer for this one here. Okay, let's say that A is greater than or equal to B. Okay, so it's either going to be the same length as B or bigger than B. So in our diagram, it's larger than B. And once again, think of it as being on a hinge, and I swing side A to the left. Okay, then there's only one possible answer for this, okay, because A will meet up at point B on the base. If I swing it past point A on this side, it would probably meet over here somewhere, like right there. But then my angle A is no longer acute, and so I can't use this as a possible triangle because my angle A measurement has changed. And so there is only one possible solution for this diagram here. Now, if we take a look at this situation here, okay, where we have that the height is less than A. In other words, the height is shorter than A, but A is shorter than B. So the length of A is right in between the height and side B. Okay, then what I get are two possible answers, okay, because A can meet up with the base right here. Okay, so remember, there's a hinge here. So I can bring A down to AB and it will meet here. And if I continue swinging it, so you see there's this red line here, if I continue swinging it along, it's also going to meet right here. Okay, and so I get two possible triangles. I get one that looks like this. Okay, so A, B, C, where this is A and this is B, and here's my given angle. Or I get this triangle, okay, where this is A, B, C, here's my given, this is side A and this is side B. So I get two triangles. I get one triangle where all my angles are acute, or I get a second triangle, and I get a second triangle where one of my angles is obtuse, and obtuse meaning between 90 degrees and 180 degrees. So with this one here, I get two possible solutions. Okay, so for an obtuse angle A, all right, and remember, obtuse means between 90 and 180. There are three cases that can occur. All right, so here's my obtuse angle A. Here's my given B. I know what A is. And here's my side A. If A is shorter than B, then remember there's a hinge. If I swing it from left to right, it never ever touches the base of what could be the triangle. So no solution. If A equals B, so they're the same length, then if I swing A, okay, there's A. If I swing that from right to left, there's only one place where it's going to touch my base, which is right here, and I don't get a triangle. I just get two sides to what could have been a triangle. Okay, so no solution again. But if A is bigger than B, then when I swing it from my hinge at C, the only place that it will ever cross over A is right here at point B, and so I would get one solution. Okay, so that ends this discussion, and we will look into it a little more deeply in our next video.